Before we build out our server, I want to give you a primer on some of the basics of RESTful APIs. An application programming interface, or API, is a way for two computers to talk to each other. Using an API is just like using a website in your browser, but instead of clicking buttons and filling out forms, you write code to explicitly request data from a server. For example, we could visit the NASA website to look at asteroids, or we could use their REST API to request the raw JSON data that is shown on the screen. Now, most APIs in the world are RESTful, which means they follow a set of rules or constraints known as representational state transfer, which has been the de facto standard for API development since the early 2000s. A RESTful API organizes data entities or resources into a bunch of unique URLs. Well, technically not URLs, but URIs, or Uniform Resource Identifiers, that differentiate different types of data resources on a server. A client can get data about a resource by making a request to that endpoint over HTTP. The request message has a very specific format. Most importantly, the start line contains the URI that you wish to access, which is preceded by an HTTP verb or request method, which signal your intent with the resource. A GET request means you just want to read the data, while POST means you want to create a new resource. Patch is for updates, delete is for removing data, along with a few other methods beyond those. Below the start line, we have headers, which contain metadata about the request. The accept header can tell the server you want the data in a specific format, or the authorization header can be used to tell the server that you're actually allowed to make that request. Then following the headers, we have the body, which contains a custom payload of data. The server will receive the request message, then execute some code, usually to read from a database, that can then be formatted into a response message. The top of the message contains a status code to tell the client what happened to their request. Codes at the 200 level mean that things went well. At the 400 level, it means something was wrong with your request. And at the 500 level, it means that the server failed. After the status code, we then have the response headers, which contain information about the server. That's followed by the response body, which contains the data payload and is usually formatted in JSON when talking about APIs. Now, an important part of this architecture is that it's stateless, which means that the two parties don't need to store any information about each other, and every request-response cycle is independent from all other communication. And this leads to well-behaved web applications that are predictable and reliable.